For this problem, we're given three capacitors. We have a 31.1 picofarad capacitor given to us right here. So a capacitor is written to us like this. Kind of looks like a voltage, but we don't have one greater than side like this. So this is our capacitor. It's 31.1 pico, and capacitance is measured in farads. Pico is 10 to the negative 12th. Now we have another capacitor right here. We have our 11, so we're going to draw this 11 picofarad capacitor, and then we have our 42.1 picofarad capacitor. So it's going to be like this. So they're all connected in series. We're asked, what is the total capacitance? Well, if we look at the engineering 17 notes, and these have been passed down because this is a continuation of EEE 117 notes. So we go engineering 17, EEE 117, and now we're in EEE 108. These are the engineering kind of pathway. But in engineering 17, I'll have these notes linked below. We have this series equation right here, where the series of capacitors looks like this, very similar to what we have right here. And this is how we would solve it. It's kind of like resistors in series, but opposite. So we know resistors in series we add together. Resistors in parallel, though, we do the parallel formula. And so a capacitor in series is basically the resistor in parallel formula. So it's backwards for capacitors. Side note, for inductors, it's the same. So it's inverted for capacitors. So we would say our C equivalent is going to be equal to, we're going to have 1 over our first capacitor here, plus 1 over our second capacitor, plus 1 over our third capacitor. This is all being raised to the negative first power. And so what we can do from here is we can plug this into a calculator, and we're going to get approximately 6.811. And so for this problem, our answer is 6.811, and that's how we would go about looking at this material.